Hi everyone, it's Tom Stevenson. We're here to talk about the database import module, which is new to the VIP in Power Monitoring Expert 8. I hope you've watched the videos on the email module and alert module that have been posted prior. We're sort of continually building on these modules as we go through this series. The database import module brings a lot of flexibility and power to Power Monitoring Expert 8, but it's also a bit of an advanced module. And I think to get us started, I'm just going to run through some simple use cases first, and then we'll build on the complexity from there. I have a blank VIP on the screen right now, so let's just start by dragging on a database import module and an external pulse, which will allow me to trigger it. The database import module is essentially a SQL query module and allows us to query a SQL Server database and bring historical data from the database back into the VIP for processing further in terms of KPI calculations. An example might be if we can query a production database and we can bring in production data that we can then normalize energy data, for example, by that production data. Similarly, if we can query occupancy data, we could bring it in from the database and then use it again in real-time calculations within the VIP, which can then subsequently be logged again back to a SQL database, or they could be displayed on a Vista diagram or in a trend or a real-time table, because we've essentially created a new real-time measurement by doing so. Some other cases include data from ETL. If data's come in from an EGX or a COMEX or something like that through an ETL package, you never really have that real-time option with that data. And again, now we could query the database to bring some of that imported data in for further calculation. The third and last, but definitely not least, is analytics. So within the context of our own database, we can extract data from it. And in doing so, we can simplify some VIP frameworks, because a lot of times if you needed to grab the energy at the beginning of the month and again, and you're using a store module to do it today, in theory, you can query for what you need. So it just depends on what you're doing. You may find some possibilities there in what you can do. And we're really interested in hearing what you do with it, because ideally we'd like to make it easier to access this data in the first place. So anyhow, without further ado, all I have done is drag out a module, and I've dragged out a pulse module to trigger it. I've pre-created a button in Vista to trigger it, and I trigger that. If I go back, I have a value of 10 on the output, and I haven't even talked about what is going on yet, just because I wanted to show how quickly you can get started with this module. And that is because a few things. We have a database connection string, and we have a few placeholders that just make it easy to connect to a database without typing out the long verbose string. In this case, I have ION data. Similarly, I could use ION network or the system log, and the module behind the scenes grabs a connection string or constructs a connection string for that database. So it's shorthand, it's secure, and just gets you going quickly. So by default, it's ION data. We've included a default SQL query in here that works. So let's just look at it. Select, and in this case, it's saying convert to an integer the value from the registry table where the name equals revision. If you're familiar at all with our database tables, you'll know that this registry table just contains the database revision. Here's the registry table. So it is selecting where name equals revision the value, which is 10. So again, we can see with the module that we're seeing our value 10 in the first numeric spot. What I really wanted to highlight first with the construction of this module, you can see that there's 32 numeric outs and 32 string outs, and we'll talk about the final outputs later. These are two banks of output registers, numeric or string, and they're an OR situation. If you query data from the database that's numeric or Boolean, it will populate this numeric bank. The string bank will remain empty. But if you query data that's of a string type, it will instead leave the numeric registers not available but populate the string registers. So you need to know in constructing your solution what you're looking for in order to link the right registers. So the example I'd like to show you quickly is this query. Now, based on some feedback from the labs program we did, originally this query just said select value from registry where name equals revision. And in this case, we get a string as our return type, and the query will still work. But what we noticed was it looks like it's not working because the first numeric is not available. But if we scroll down, we can see now that it did populate the first string output because that's the data type that was returned. So by adding the convert there, we ensured it went into the first bank. And this is just so that it doesn't confuse anyone that the module's not working. So there we've talked about how quickly we can get up and going with this module. Let's now just talk about query construction. Now again, this is something that you have to be comfortable with yourself. And what I'd also suggest as we move into this video is that when you're looking for information in the Power Monitoring Expert databases, that you first look to the views. The reason being is that you may be aware that the table structure does start to change over time. And this is great if you're selling support contracts and you have the ability to go back and update your solutions with the customers, if you do anything like this. But if you use the views, historically we've generally tried to keep the views unchanged, such that if we change the table structure, the views continue to work as they do. So it's definitely a layer of abstraction for you to consider. So the next example I wanted to look at, I am going to use the data log channel view that is shown here. If you haven't seen this view before, it's really a source measurement pair view. You can see that there's a column for the source name, for the namespace, the timestamp in UTC, so it's not corrected to local time. The value looks very much like a frequency, and sure enough, the quantity name is frequency high. And there's a large table of them here. Now, when you think of that bank of 32 registers in the module, they are corresponding to the first column of your query. So when you construct your query, you really need to pay attention to what you're querying. If I were to query all this information, I'm not going to use anything that's outside of the first column. And if I query more than 32 rows, I'm querying more than I can expose to that module. So that's the first two sets of constraints in both row and column to consider. Now to illustrate this, let's take this sample query from the Management Studio, which is a great way to actually construct your queries in this way. I am going to select the top 32. So the first execution of the query shows that I only get 32 rows back. Perfect. That's all I can show. If I don't change anything, I should fill all my output registers with Bertram.7650, which is the main meter in the building I'm in. When we move this to the VIP, we can remove all of this information here. So let's do this experiment. Take this query and move it into the module. Okay. I'll trigger the query. Now you can see for the string, the bank of string output registers, we filled them with Bertram 7650. If it was the values I wanted, I would simply move that into my query. Now, is that the numeric bank will be filled with all of those frequency values. So the primary objective of me showing this, it's not the most useful query, but I wanted to illustrate how you construct your queries to return 32 or less rows, and how to focus on the first column of the data set you are interested in bringing back. Where it does start to get interesting now is where you can leverage some of the power of SQL Server if we wanted to ask for the maximum frequency value. And if I test this query, before, okay, and this is looking for the max value now in the entire database, in the entire view here. So we're getting a large value. I would want to refine that down to a specific quantity or measurement or source. But I wanted just to illustrate how you can quickly start to pull out analytical information if you are comfortable in the SQL domain. I can just illustrate that now within the query module itself. And there's our big number. So like I mentioned before, these values we start to bring in can now be linked and shown in Vista or the web just via a display object. Similarly, I could trend it, what have you. There we go. So we've taken data from the database and brought it full circle back into the real-time domain. Okay, so we've talked about using the views to abstract yourself from future database changes. We've talked about how to construct your queries and how that maps to the structure of the database import module. Let's put in a real query now, one that I've been playing with the concept of smart mode measurements in mind. I just have it here for convenience. So again, I can use the Management Studio to really test what I'm doing first, to find what I'm looking for. And what is this query doing? Select the minimum value from the same view, my source name of interest, which is the main meter on the Bertram building here in which I'm sitting. I'm going to query power factor. It's an ion meter, so I will look at the leading and lagging measurements together. And I also want to look at the minimum value within the last month. So what this is doing is converting the UTC timestamps to the local time in the query and saying anything that's greater than a month ago. If I wanted to do a week, I could WK instead of month, or a day if I wanted to do the last day. So we can adjust how much we are looking for the minimum in. I'll keep it at month for now. If I execute this, what does it tell us? It says the Bertram building. Now this is an office building we're in. There's nothing terribly exciting. Maybe what we should do is change over to Keating, down the street where they manufacture the power meters. They can sometimes have more interesting data. There we go. That's not such a healthy power factor. 89. So in the last month, from the point I'm running this now, we can see that the lowest power factor we recorded was 89. And again, let me just demonstrate the week piece. Oh, it was in the last week that happened. Day. There we go. In the last day, 92 was the lowest, 92 and change. Okay, so I hope that gives you a feel for what the query is doing. Let's bring it now. We see it working in SQL Management Studio. Let's bring it into our database import module. There we go. Let me trigger it now from Vista. Okay, we can see our worst power factor now showing up in Vista. So again, we can potentially, we just want to do the KPI view within our Vista or web diagrams. We can say worst power factor last month. That might be of interest. If we took the, we have to pay some attention to the device type. If they were all ion devices, so that measurement name is okay to use. We could query more than just the one. We could query the worst power factor in our facility potentially, just depending on what we're trying to do. Okay, we have that now. Okay, I want to talk about the external string module, which if you watched the email and alert module, you saw is used to provide string content into an email message or an alert SMS message. In this case, we can use the string module now to pass optional arguments. And in this example, I will just use the meter name. Make sure I remember what the meter name is. I have Keating.7650. We can now see at the input to our database input module at argument 1, I have a string value, and in my query, I can then replace this quoted Keating7650 with &1. It will look at the data type at the input, see that it's a string, and it will quote the value I programmed in that module. So as you might expect, if I come back and trigger this, I should get the same result I saw before with an 89.5. What's interesting here, we can bring the string value out onto our Vista diagram. Yeah, I might need to actually take the handle for it. Two 700-102. Okay. You might have noted that I also have my Bertram meter. So what I pulled this optional argument out, I can now program on my screen a different name. This can be done This is just one application. The other one is just portability of your framework. If you move it to another customer system, you can then just change the name of the meter. But I can also, just for fun on this diagram, change the name of the input, trigger the module again, and I can see for Bertram, the worst power factor last month was 99.2. So I hope that illustrated what we can do with the optional inputs in the external string module. Okay. Let us do one more example. This one's fun. Here I looked up in a Google search a query to find out what's the size of my database. And this one's interesting because it lets me illustrate another consideration in your solution design to you. Okay, so I've run this query straight out of the Google page, and you can see I get a row of data, ion data, the log size, the row size, and then the total size. So I have a 4.2 gig SQL Express database. So what might be interesting is to set up an alarm or a notification when this database size would drive me to trim it or to archive it or what have you. Now, from what we've talked about already, you might notice that if I want this piece of data in my framework, I need to reconstruct my query. Now, I really don't care about these other things, so I'll just remove them. So select total size. This is now perfect. One row, one piece of data. Now, the second consideration that this will highlight now is the connection string. I will point out the number one troubleshooting piece that will be encountered in that we're asking the master database now for this information. And when I trigger this query, the first thing I will notice is that I didn't get my value. I happen to know that to query the database size from the master database, that you will need some certain permissions. When you use these default connection strings, they're using the report user that's already created in the Power Monitoring Expert database, and it's a read-only user. So if you do need to have something that has a little bit more privileges, you need to modify this connection string. Now in this case, I've created myself a user with the specific permissions. This is one alternative. The other alternative is just to give the report user that the module is using and grant it permission on the user-defined function, the specific database. If you wanted to query the network database, for example, you would need to give the report user access to the network database. Or create yourself a custom user with the permissions you need, which is what I've done here. And the user's name is Tom and the password is 123. And I can put that custom connection string in here. And again, if I trigger this, we now have our database size into the VIP. I need to talk a little bit about security now. We've put the credentials of a pretty powerful SQL user into a text string, and now that we see that the solution is working, I want to obfuscate that so that no one can see what my user and password is. So I've tested that it works. This is a one-way encryption, and you'll notice, like I showed you with the email, when it's done, I have an encrypted value in the connection string, not human readable. And if I execute the query again, we still get our result. So there it is, secure. Just to touch on the smart notification topic a little bit. We'll do another video specifically on this. But we have some values coming into the VIP. And in this case, I can just leverage some of the modules that we already know to create alarms. So I mentioned the SQL alarm, first of all. And in this case, let's create two. The first one, we will say at, let's say 5,000, 6,000. So it's 6 gigs. We want to alarm. We'll link the new email module, which you've watched in a previous video. Take the trigger, trigger the new email. The subject will be alarm, SQL Express database approaching need for maintenance. That's the subject. If I want to be fancy, the current database size is %1. And if you saw my email video, we can new source and also link the size. So in our email, it will tell us the explicit size. And I didn't adjust the priority on this one, which is normal. But what I will do is set up a second email. I'll just cut and paste this module, not maintain the external inputs. So the trigger will be from the second set point. I will set the priority of this email to high. I still need that one input argument to show the size of my database. And this second set point module, I will set to 9 gigabytes. So as I'm sending a high priority email when it gets this close to size, as I might be risking my database filling up. And I've forgotten something. Okay, SMTP server. I'm just going to put in a dummy IP or name for now. Okay, so using the VIP logic, we've created some smart notifications for database size. So SQL Express system, we want to be notified if something's going on. We might also get creative with some of the other database growth stats that you can ask SQL Server for as well, and predict when you're going to need maintenance. But let's leave that for a future video. The other one, if we move back to our Keating meter, we saw that it was less than 92 on the Keating building. So what if we sent ourselves a smart notification every month? We'll take the value. Okay. If power factor now drops below 92, we want to create either an alarm for ourselves and or a notification. And we can trigger it. We will change our external month now to be likely new month. So every month we'll just run this query to see in the last month, did we see anything that was less than 92? And if we did, let's send ourselves an email. So I'll fill in a pretend server host for now. These details were covered in the email module. I already put together an email subject. Keating building, poor power factor is likely contributing to higher costs. For the subject of the email, I've already created a template called reliability power factor.html. If I open up this template, which we can modify in Notepad or what have you, whatever. The worst power factor last month was below the value at input 2 for device valued at input 1. Low power factor can incur penalties on your bill and can also cause increased maintenance costs. So at the HTML template level, again, if this is not familiar, watch the email video where this is covered in depth, but we specify we want the reliability underscore power factor template. So I get a beautifully formatted email. And we need to link a couple of inputs to get the values. The first value was the name of the meter. We already have a string constant for that. And the second value was the worst power factor, which comes from our database import. And there you go. We have a smart notification monthly if we saw a power factor that was below 92. So Jacques Van Kampen will get an email for his Keating building in the last month. And as you might imagine from this Vista diagram I'm setting up here as well, you can potentially add an enable to this framework and have yourself opt in or opt out of these smart notifications. We could set up a whole diagram for the ones we want to offer. So there'll be an upcoming TBD on this in more detail, but I think I'm just illustrating the possibilities here. Okay, so if I'm interested in my worst power factor last month smart notification, oh, I'd like to get that email. Yes, here we go. And if I was even interested, I could also link the setup register for the to address in the email module, such that we could add Joe at acme.com. You could actually include your name on a potential smart notification subscription. And maybe the last point I will touch on is troubleshooting. I mentioned before that probably the one that I've encountered the most in prepping for this video is permissions. So to diagnose those, typically there'll be either an error message. Use the Management Studio to try your queries out first to make sure they execute. If they execute there, you can also log into the Management Studio using the credentials of report, the user that the VIP module uses by default. So there's ways to diagnose if it's security or permissions. And then the other friend you have in this is the Management Console and the system events. And just to quickly highlight how that works, I've added a default database import again. If I trigger it, I have my value of 10. Let us just make a mistake in the framework, in the query. So I put in something that's not correct. If I trigger once again, I will see that I did not get my value. What I may see if I look at the value of the outputs, okay, it's because I got the framework open, but if I move to my Management Console, system log events, I'll refresh that. You'll see that I got an error, failed to query the database. Reason, type IXNT is not a defined system type. So you'll see there that it's calling out, the message is coming from SQL Server itself, that it recognized that a syntax error. The other output register of interest is the processing time. So in milliseconds, you can tell if you're querying way too much information. If I said select star from data log 2, and I execute that query, you'll see that I have my values now, and the processing time was 48 seconds. Way too long for a VIP framework. Now, it is processing this module offline. It's not going to delay the calculations of your other modules, but if you were triggering a recording now based on the load complete register, it would be 48 seconds later. It's something to be mindful of when you're designing your queries again. In this case, I'm querying way too much data, more than could ever be returned in a single module, so I would want to refine it. So this processing time, a lot of times you don't even see the milliseconds. Larger queries, you may see some milliseconds. When you start getting really large numbers like this, it should give you pause. And then load complete. I mentioned before too, if we were doing a KPI calculation, we wouldn't want to trigger the recording until we know the database has come back, the query has come back, so we can use that load complete as a record on other KPI calculations. Okay, I hope you found this video helpful. I wish you the best of luck with the database import module. Again, the SQL Server understanding will be key again to the success here, but to help remedy that, expect to see some TVDs that utilize this module where we've got some constructs already laid out, so it's more of a commissioning effort. Thanks very much, everyone.